Hello there. Welcome. Welcome to Math Simplified for You. My name is C. Ramakrishnan. And in today's class, we'll be dealing with graphs of continuity. If you can draw a smooth curve without lifting the pen off the paper, consider the graph to be continuous within that domain or interval. But what happens if you see a dark circle, a hollow circle, or a combination of dark and hollow circle? What would you do? Then the answer to that question lies in today's video, where we will be analyzing continuity graphically. So the three conditions of continuity is listed here. We will check one by one for each graph. Is fx defined at x equals to a? What does that mean? It means if I put x equals to a on the left hand side, am I getting a defined value on the right hand side? Which means I should not be getting a 0 in the denominator. If I don't get a 0 in the denominator, it is defined. But how do I see that graphically? If you see a dark circle on the graph, above the graph or below the graph, does not matter. You can claim that f of a is defined. So yeah, here we see a dark circle. So yes, if I put x equals to a, I get f of x. That means I get a defined value for x equals to a. So yes. What about this one? I said dark circle, not hollow circle, but here we are saying a hollow circle. So no, it is not defined at x equals to a. What about this one? Well, you have a dark circle here, never mind, even if you have a hollow circle, but for x equals to a, we get a defined value for y, which means yes, it is defined at x equals to a. What about this one? Yes, you have a dark circle and at x equals to a, you will get a fx. So yes, it is defined at x equals to a. What about this one? Is LHL equals to RHL? How do I see that graphically? If I draw the curve from right to left or left to right, if they align, they may or may not meet. That's a different issue. Okay? If they align, you can claim LHL equals to RHL graphically. Here, yeah, whether I draw from right to left or left to right, they align. So yes, it is LHL equals to RHL here. What about this one? Yes, LHL equals to RHL. But is there any use in checking that? No. Why? Because the first condition is not satisfied. And as per the rules of continuity, if the first or second or any one condition does not satisfy, then of course it is not continuous. So no point in checking this. What about this one? Yeah. Is LHL equals to RHL? No, it is not. Because if you see whether I come from left to right or right to left, I said what? It should align. But here, no. One is above the other. This kind of discontinuity is called a jump discontinuity. So of course, LHL not equals to RHL. What about this one? Yeah, LHL equals to RHL. Because whether I draw from left to right or right to left, they align. So yes. What about this one? Is LHL equals to RHL equals to f of a? The last and the most important condition perhaps. So how do I check that graphically? If I see that the dark circle lies on the curve, then yes, LHL equals to RHL equals to f of a. In the first condition, we see yes, the dark circle lies on the curve. What about this one? No point in checking. What about this one? No point in checking this as well. Why? Because the second condition is not satisfied. What about this one? Yeah, LHL equals to RHL, that's fine. But the dark circle does not lie on the curve. What does that mean? LHL equals to RHL but not equals to f of a. So the answer is no. So from this graph, we see only the first one satisfies all the three and we can claim this to be continuous. Now that the graphs of continuity is so clear to you, why don't you see this video once again, take notes and teach a friend? The best way to get confidence. You are always welcome to share, subscribe, follow and do whatnot. Thank you very much. This is C. Ramakrishnan from Math Simplified for You.